actually kani si kinematics o si kinetics rather, no? So as I mentioned last meeting, no, or during our course orientation, that the subject dynamics mura lang yun siya o physics, no? Okay, anyway, um, so under kinetics and kinematics, we have translation, rotation, and plane motion. So these are the systems we are dealing with most of the time, no, sa ato ang dynamics, no, kani si translation, rotation, and plane motion. It's just that we have different considerations, no. So dara na mo sulod si kinematics o si kinetics, no. So have considerations for kinetics of translation and as well as kinetics of translation, no. So at so on and so on and etc. No. So for kinematics of rotation and kinetics of rotation, then kinematics of plane motion and kinetics of plane motion. So those are our main focus here in dynamics. So most probably sa ako ang pag-project, no, I think ang coverage na to sa to ang midterm or until midterm na to nga topics would be ano lang gitataman siguro ay translation since translation has two classification. We have what we call rectilinear translation and curvilinear translation. So when we say rectilinear translation, that is ang iyang consideration ana no or iyang movement niya ana is along a straight path only no or along a straight lang iyang motion kibali no. And then sa curvilinear translation, so as the name suggests, curvilinear. So ang iha pong gina travel nga path is naay mga curve no or gina-consider na to ang curvatures kibali sa to ang path. So that's for translation. And then for rotation, so rotation, kailangan mo rotation, no? So circular motion. And then for plane motion, this is the combination of translation and rotation. So basically, much complicated siya, no, compared to two since two systems to combined into one, and that is plane motion. Okay, however, again, for midterm nga topics, I think ano lang siguro tataman, translation, no? So both kinematics of translation and kinetics of translation for rectilinear and curvilinear translation. But I hope also na masulod na to ning topic nga rotation no within midterm pa lang alone kay para excuse me kay para sa to ang final term maka-focus ta sa to ang plane motion and also napamagud tay last topic no after this one. So supplementary topic niya siya actually, which is ato ang kinetics no of a particle with regards to work, energy, impulse, and momentum. So muna siya to ang last yun nga topic for this subject course dynamics. So sige lang no. So I'll try my best na ato ni siyang makover tanan ato ang syllabus. Excuse me. So principles of dynamics. Again, dynamics is divided into two branches, diba? So we have kinematics and kinetics. So now, let's define and differentiate no, in order for us to distinguish the differences between these two branches of dynamics. So kinematics rather, no, it is defined as the geometry of motion. It is used to define the motion of a particle or body without consideration of the forces causing the motion. So clearly, kinematics that ang consideration nato sa kinematics is that ano lang no, we are focused on or we are studying on the focus on the movement of the body alone. So dili na to i-consider ang force nga nag-cause sa iyang motion, no? So of course, dili magyud dili magyud na mulihok ang isa ka butang kung walay unbalanced force nga na-apply ana siya ana nga body. But here in kinematics, ang ato ang main consideration is just on the movement of the body alone. So dili na to i-consider tong force nga nag-act sa ato ang body or force nga na-apply sa ato ang body para mag-cause siya og motion, no? So it is also used to relate displacement, velocity, and acceleration without reference to the cause of motion. So ginabalik-balik yun siya, no? Na without reference to the cause of motion. Okay, sorry class, murag, I think paspas kayo kumusturya. Basin, basin,
Okay na,
nai,
sir.
basin na sa
Okay
evaluation
lang,
ba? No,
sir.
paspas kayo musturya si sir. Bitaw. Anyway, I hope makaka-catch up yapon mo. Makaka-catch up yapon mo. Kay ako siyang ginadali pod kay para pod na you'll have extra time no if ever na tayo mabilin nga time. Kay I think more na amoy activity na deadline this 5 p.m. So at least maybe I can help no. So our schedule is 3 to 5 p.m. 'di ba? Anyway, di kani siya ako ang na-prepared nga discussion for today. Ang estimated na ko ani is ano laman po no, ano, 1 to 1.5 hour nga discussion. So sige lang. Okay, so asa na galita? So it is used to relate displacement, velocity, and acceleration without reference to the cause of motion. So again, sa kinematics, ang ato ang consideration is focused on the displacement, velocity, and acceleration alone. No? So walay labot or dili involve ang force no nga nag-act sa ato ang particle for it to move no or for it to cause its motion. So I hope na-get si kinematics. And on the other hand, we have kinetics, no? So in contrast si kinetics no to kinematics. Since in kinetics, it is the analysis of the forces causing the motion. So isa kinematics, dili na to gina-consider ang force nga nag-act sa ato ang particle for it to move. Then here is sa kinetics, part na siya sa ato ang analysis, no? So it is clearly stated that it is the analysis of the forces causing the motion. Kinetics also defined as a branch of dynamics that relates the forces acting on a body to its mass and acceleration. And also, it is the study of the relation existing between the forces acting on a body, the mass of the body, and the motion of the body. So, gabalik-balik ang definition no, or murag gi-reinstate lang siya in different ways or in various ways. But ang ihang point is that it relates the forces acting on a body to its mass and acceleration. So from this definition, you can draw or you can conclude that kinetics is actually based on Newton's laws of motion. So especially ang second law of motion in Newton. No? So if you recall from physics that we have three laws of motion by Newton. So originally, actually, ang inspiration po na ni Newton is si Galileo. No? So I know familiar na mo with Galileo, but ang concept po na actually ni Newton is na-learn niya kang Galileo, no? So, since una man si Galileo sa iya, and ang studies and experiments ni Galileo, gitiwas ni Newton, then siya ang nag-create, no? Sa iya, sa three laws of motion. Okay. So, again, kinetics is mainly based on Newton's laws of motion, especially ang iyang second law of motion, which is katong force, no? That the force is kung ano, the force acting on a body is directly proportional to its acceleration. From ha. Okay. So moving on with the kinematics of a particle. So for this session, no, ang layout kibali or ang outline no sa ato ang agenda today is more on kinematics and kinetics, no. So atong i-define some terms no or some important terms for with respect to these branches of dynamics no. So mura lang siya overview gihapon sa ato ang systems no sa kinematics and kinetics. So the kinematic okay, the kinematic of the motion of a particle depends upon the definitions of displacement, velocity, and acceleration. So again, as mentioned earlier, that the kinematics of a particle is dependent no upon or dependent on the definitions of displacement, velocity, and acceleration alone. So walay appeal si force. So first, displacement. So more likely, displacement belongs to position, right? So position, we know that it has a scalar and vector quantity, and these are what we call the distance and the displacement. No, so distance is the scalar quantity, and it is defined as the total accumulated length of path traveled by the particle. So um, since it is scalar, distance, ang magmatter lang sa iya is ang iyang magnitude lang no, or the quantity of the distance, no. So dili magmatter ang iyang direction. And then on the other hand, si displacement is a vector quantity, and it is the vector distance from an origin to the position occupied by the particle on its path of travel. So the path length from the final position relative to the original position. Okay? So displacement, ang iya lang kuan ani is yung basis lang is ang iyang final position and ang iyang initial position, no. So the length of that path from its initial position to the final position lang imong i-consider. And also since it is a vector quantity, so magmatter ang iyang direction, no. So it has both the magnitude and the direction of your displacement. So why is it important to distinguish between distance and displacement? It is because all the kinematic relations we are dealing or we are about to develop here in dynamics involves displacement and not distance. So to avoid confusion, it is important na you know no kung unsa inyong ginagamit sa inyong calculation or sa inyong computation, if it is distance or displacement, since basically dara pud mag-start no ang error sa computation. Okay, so let's have ano siguro no illustration or sample illustration for distance and displacement to better understand these two or the difference between the two. Okay, wala pa dahil kung naka-prepare o kung ano, whiteboard. So, actually, I was planning nga dere sa PowerPoint lang ko magsulat-sulat. However, again, kaganina sa ko ang first, excuse me, sa akong first class kay dili na po daw makita ang akong ginasulat sa PowerPoint. So, dari na lang yun sa ito ang virtual whiteboard, no? Provided by Google Meet. Wala, sir. Okay, for a while class, I'd like to ask, nakita ba ninyo ang presentation earlier? Ang
Yes po,
PowerPoint?
sir.
Yes, sir.
Yes, sir.
Okay.
Yes,
I
sir.
guess I thought kani mo ang pasabot ni Joby no nang wala, sir. Sabi na ko wala nakita ang PowerPoint. Anyway, let's na-share na siya. Wala akong okay. So, distance and displacement na ako na lang i-butang sa title. So, let's have situation number 1. Let's say a particle is or travels from point A to point B. So, muna lang yung statement. No? Then, let us determine the distance and displacement. No? So, Oops, for a while. Particle, naunsa man eh. A particle travels from point A to point B. So let's say this is point A. So pardon my handwriting na lang no kay lisod siya. And this is point B. So a particle travels from point A to point B daw. So ato ang distance for this situation is just equal to AB, no? So line AB lang ang iyahang distance since it is the accumulated length of the path traveled by your particle or your body, no? So for the displacement, pila man nato ang displacement no in this situation. Since again the definition of displacement no relative daw kuno sa position, I mean final position and original position no. So the difference between final and initial position, since point B ang ato ang final position and point A ato ang original position, therefore ang displacement pod niya no is just equal to AB. So let's say for situation number 2, a particle travels from point A to point B and reversed its motion back to point A. So the same scenario actually, but it's just that after reaching point B, nibalik daw kuno no ang iyahang direction kang point A. So again, this is point A and point B. So sumpay na siya class no, naputol lang siya. So let us determine distance. So yung distance no, since again the definition of distance is the total accumulated length no traveled by your particle or body. Therefore, ang iyang total distance is AB plus BA. And then iyang displacement, so pila man nato ang displacement to in this case. Displacement. So displacement no in this equation is equal to 0. So nganong 0 man? Because again, definition sa to ang displacement is that it is no the distance from an origin to the position occupied by the particle on its path of travel, or the path length from final position relative to original position. So since ang ato ang final position is naa siya kang point A no, kay ni travel man siya from point A to point B, then nibalik siya kang point A. Therefore ang ato ang final position is naa kang point A, and also ang ato ang original or initial position is si point A, which means that 0 ang iyahang nahimo nga displacement. But na siya value no as to the distance traveled by your particle. So diri nato makita no ang difference nila, or diri nato siya ma-differentiate si distance and si displacement. So another example for this is sa circular motion no. So if a certain particle starts its motion and it is moving in a circular path no, then if makabalik siya tong a certain point nga asa siya nag-start, then at that very point no, or at that point 0 ang displacement nga nahimo sa imuhang particle or sa imuhang body. So let's have another or last situation na lang for distance and displacement no. A particle travels from point O to point B and reverse its motion and reaches point A. So we have here another situation no, nga a particle travels from point O to point B. So let's have the original position or the initial position, si point O. Then it travels siya kang point B. And then after reaching point B, reverse daw kuno iyahang motion no, or nibalik siya sa iyahang agi and reaches point A. So let's say na diri si point A no. So let us determine the distance traveled by your particle. So distance, again, total accumulated length traveled by your particle, OB plus BA. No? Muna yung total distance na travel niya. And then for the displacement, so displacement is equal to, so final position nato is si point A and original position nato is si point O. Therefore, ang iyahang displacement is just equal to OA, no? So ana lang siya. I hope nag-gets ni sila no ang ilahang difference. So balik lang sa ato ang PowerPoint. For a while ha.
Naka-mute ka, sir.
Okay, so thank you sa pag-remind no. Anyway, moving on. So the next consideration nato no in kinematics of a particle is the velocity. So velocity is defined as the time rate of change of displacement. So muna iyang basic definition of velocity. And the average velocity will be given as excuse me. Average velocity is equal to the change in displacement divided by the time interval. So that's how you find average velocity lang no. So common kayo ni siya nga formula or basic kayo ni siya nga formula sa ato ang velocity, or it is also known as, or it can be written as final position minus initial position divided by the time interval. So muna to ang basic formula no for velocity. Okay. So instantaneous velocity. So unsay may pasabot sa ato ang instantaneous velocity no. So sige na niyo ni siya og kadunggan no, or sige na niyo ni siya og ka-encounter since from high school pa lang no, physics na to sa high school na introduce na ni sa to sa instantaneous velocity. So instantaneous velocity refers to refers to the velocity of a body at a certain point no, or at a certain time or at a certain position. So instantaneous velocity refers to the velocity at any given time. So from the root word instant no, at hand or at the moment. So muna siya ang pasabot ni instantaneous velocity at specific time. So pila iyahang velocity. So um the instantaneous velocity as delta t approaches zero will be given as limit of the change in displacement over time interval as delta t approaches zero, which is just equal to ds over dt. So velocity or the instantaneous velocity is equal to ds over dt. So unsa pa ipasabot ani ato ang ds over dt no? So from our differential equations, so if you recall no, this is the first order no ang ato ang ds over dt, which means that velocity is the first derivative of your displacement. So importante kay na siya nga knowledge class no, or importante kay na siya nga understanding that the velocity is the first derivative of your displacement. So mao lang na ihambot ipasabot. So speed. So again, the same thing with displacement and distance. Pag abot sa tong velocity, we also have murag iyahang similarities no, or familiarity no, that mo siya si speed. So speed is defined as the magnitude of velocity. So when referring to speed, it is the rate of change of distance, no? So velocity, displacement, then speed, distance. So sila ang partner kay bale, no? So happy Valentine's Day na lang sa kang velocity og speed o displacement og distance, no? So na sila partner. Again, speed is a scalar quantity because again, distance is a scalar quantity and ang gina-consider ni speed is ang distance, no, dili ang displacement. That's why speed is also a scalar quantity, which is just the magnitude of velocity lang, no, since the same lang man ni sila. It's just that the velocity is na siya direction, no, or it is a vector quantity, which means that it has both magnitude and direction. So formula for speed is equal to distance traveled, no, over time elapsed. So very basic lang ihapon. Okay, so our last consideration here in kinematics of a particle is the acceleration. So acceleration is defined as the time rate of change of velocity. No? Then velocity is defined as the time rate of change of displacement. So that's how they are related, no? Si displacement, velocity, and acceleration. So connected lang yun sila, class. The average acceleration will be the difference between initial and final velocities divided by the time interval. So the same thing with, or the same formula with average velocity, no? It's just that here, ang yaha is change in velocities since acceleration is defined as the time rate of change of velocity. Therefore, we have average velocity, average acceleration, no? So average acceleration is equal to the change in velocity over time interval. Or it can be written as final velocity minus initial velocity all over time elapsed. So, ana lang, no? Ang pag-compute sa tong average acceleration. And then, instantaneous acceleration as delta t approaches zero will be given as a limit of delta velocity, or the change in velocity divided by the time interval as delta t approaches zero, which is equal now to dv over dt. Therefore, as definition, acceleration is equal to dv over dt, which implies that acceleration is the first derivative of your velocity. No, so if nakay velocity, if imo na siyang i-derive mo na siya ang imuhang acceleration. So pwede ra nimo gamitan og calculus, no, or differential calculus to compute acceleration, velocity, and displacement actually. So that's how powerful ang definitions, no, sa ato ang displacement, velocity, and acceleration. So as a summary, no, of our kinematics of a particle, no, so we have here the differential kinematic equations of motions, and these are the following equations, no. Velocity is equal to ds over dt, or the first derivative of your displacement, and acceleration is equal to dv over dt, which means that it is the first derivative of velocity, no. So we have here another definition of acceleration, that it is equal to d squared s over dt squared. So nagpasabot ni siya na uh, acceleration is the second derivative of your displacement. So natingala mo, no, nikalit lang to nga si d squared s over dt squared. So sige lang, we'll try to derive this one, no, if asa ni siya gikan. Pero very easy lang yun siya, class, no. Ato lang i-substitute ato ang definition sa velocity. And then kanipod si VdV is equal to ADS. So this is actually the three differential kinematic equations of motions, no, that we are, or that we will be needing, no, to solve problems, no. So mag-derive po ta of formulas using these relationships also. So next meeting, we will have ano man, introduction sa to ang translation no of translation nga motion, more specifically ang rectilinear translation. So sugdan na nato ato ang rectilinear translation. So for now ato sa ni siyang i-derive. Let's try to derive asa ni gikan sila nga formulas. For a while. Na-share na ba ang wala pa. So this is the relationship of instantaneous velocity and instantaneous acceleration. Okay, so asa man gikan si d squared s over dt squared, no? So actually, gikan lang po ni siya, no? Or na-derive lang ni siya sa definition ni the acceleration and the velocity, no? So acceleration is known to be dv over dt. And we also know that velocity is equal to ds over dt over dt. So simplifying, you'll have acceleration or you'll have this form na pod, no? Na d squared s over dt squared. So what happened here is that um, so d squared s over dt times the reciprocal of over denominator dt, no? So 1 over dt lang yapon. So as a product, you'll have d squared s over dt squared, which is muna ni siya nga form. So you actually have a direct relationship, no, between acceleration and displacement. And for this case, can you see VdV is equal to ADS. Dari po na siya nga relationship gikan, no, definitions or equations, no, of our instantaneous velocity and acceleration. So we know that acceleration is equal to dv over dt, and velocity is equal to ds over dt. So if atong i-express ato ang time elapsed, no, or dt, difference in time, in terms of dv over acceleration, so you have this form. And also, sa instantaneous velocity, no, we will express dt in terms of ds over v. And by equating them, so you will have this form or you will achieve this equation dv over a is equal to ds over velocity. So by cross multiplying vdv is equal to ads. So dali lang po na siya na-derive no nga equation. Okay, so balik sa to ang PowerPoint. So these equations are the statements of fundamental definitions of instantaneous velocity and instantaneous acceleration. No, so we define the relationship or we find the kinematic equations of motions no, with respect to displacement, velocity, and acceleration. Since kinematics of a particle focuses on the movement of the body alone. No? So the ang main focus is ang displacement, velocity, and acceleration of the body alone. So, wala na ito i-consider ang force. Okay. So, for kinetics of a particle naman, so as a recap, no, let us recall Newton's laws of motion first. So, the first law or the law of inertia states that an object at rest remains at rest and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. So there are actually various ways of statements no as to the first law of motion ni Newton. But in engineering mechanics, we can also phrase it as a particle acted upon by a balanced force system has no acceleration. So, muna iyahang ano no, first law of motion or also known as the law of inertia. So, the second law of motion is that the acceleration of an object depends on the excuse me, depends on the mass of the object and the amount of force applied. So, in engineering mechanics, it can be stated as a particle acted upon by an unbalanced force system has an acceleration in line with and directly proportional to the resultant of the force system. And the third law, or what we know as action and reaction, it states that whenever one object exerts a force on another object, the second object exerts an equal and opposite on the first object. So the action and reaction of forces between two particles are always equal and oppositely directed. So of course, if mag-apply ka og force no on a certain particle or body, that body will have the tendency to resist no or ihang i-resist ang force nga imuhang gina-apply no. So iya siyang i-resist to the point of equal ang ihang magnitude and opposite ang direction. So this is what we call the action and reaction nga law nato on motion. So the kinetics of a particle with respect to force and acceleration alone. So wala nato i-consider ang work, energy, impulse, and momentum. So ang ato sang i-consider as of now is ang kinetics of a particle with respect to force and acceleration. Then the fundamental equation for that kinetic is we have this formula R is equal to W over G times acceleration or times A. So A there refers to the acceleration of the body, W is the weight of your body, and G is the um, gravitational constant no or constant of gravitational force Then R refers to the resultant force acting on the body. So again, no, resultant force ang ato ang R. So it is stated or defined as the resultant of the applied external forces is equivalent to the product of the mass of the body, and the acceleration of its center of gravity. So let us try to derive this no kung asa ni siya gikan. Masig matingala mo nga nikalit lang to nga si R is equal to W over G times A. But actually, if inyong tanawon no or if inyong analyzon, mura ra na siya og F is equals to MA, right? No, so it's just that the force here refers to the resultant force no acting on the body, then equal to mass times acceleration. So we know that weight is equal to mass times gravity. So if atong i-express ang mass in terms of weight and gravity, we will have an equation, mass is equal to W over G. And if imo siyang i-substitute sa equation nga F is equals to MA, you will have F is equal to W over G times acceleration. So, mo lang na siya, no? But let's try to, view this in another angle. Awan. Okay, sorry. Okay, so let's try to consider a particle acted upon by an external forces, no? So you have, let's say, force 1 or P1, P2, and etc. Oops. And then the weight of your particle denoted as W. So let's say that the resultant force of these forces acting here. So siya i-denote as RF. So based on Newton's second law of motion, that the force is directly proportional to acceleration. Acceleration. So if we'll try to create or if we'll try to, what do you call this? If we will try to have a mathematical equation for this, no? We'll have this relationship, no? That force is equal to some constant of proportionality and acceleration. So in this case, our force is the resultant force, no, acting on the body, equal now to the constant of proportionality times acceleration. So to determine the proportionality constant, let us also consider another situation, no? But the same lang ang particle, no? So let us consider the same particle to be in a vacuum. So um, I I know kailan na mo no kung unsa si vacuum, but as a recap, vacuum refers to a space devoid of matter, no? So vacuum is actually a space, no? It is a free space or an empty space, no? It has no air or pressure, no? So absent ang different kinds of matter. Okay, dari na lang sa kilid. So let's say we have that the same, alam mo vacuum. The same particle. So, naa siya sa vacuum. So, the only force nga nag-act sa iya no, is ang iyahang weight, which is denoted as W. And there are no other factors or components nga mag-act sa iyahang nga force since naa siya sa isa ka vacuum nga space. Therefore, the acceleration produced by the weight of the particle or the W is the gravitational constant G, which with which acts in line with the W, no, or ato ang weight. So ang acceleration nga iyang na-produce is just the acceleration due to gravity. And again, based on Newton's second law of motion, that the force is directly proportional to the acceleration. So we have this F again is equal to KA. So in this case, our force nga nag-act lang sa iha is ang iyahang own weight, which is W, equal now to some constant of proportionality K, and then acceleration. So acceleration sa body is acceleration due to gravity. So I can write this one as Kj. So we now define we can now define the proportionality constant K, no? Which is just equal to W over G. So by substituting that parameter, no, atong i-substitute ato ang obtained proportionality constant sa ato ang real world scenario here, we'll have RF is equal to K is W over G times acceleration. So, mula na siya, no? Muna ang concept behind the formula or the concept behind the fundamental equation of kinetics of a particle. So again, this is just the fundamental concept of kinetics of a particle with regards to the force and acceleration. So wala pa ta niabot sa kinetics of a particle with respect to work and energy, impulse and momentum, no? So kanilang sa atong unahon. So later part na to siya ang ato ang impulse momentum rather and work and energy, no, para mausara po nato siya dito nga discussion sa to ang impulse and momentum and work and energy. So I think that's it for today. So basically principles lang gyud siya, no, or concept lang gyud nato nga gamito nato here sa to ang dynamics. So next week sa to ang session, next meeting, we'll have ano we will apply this concept na no and principles sa to ang different applications no which is silang translation, rotation and plain motion. But again, unahon pa nato si translation. So next week atong topic is about rectilinear translation and we will apply these basic principles na to ang gipang ako ang gipang introduce today no. So any questions or clarifications? Ay for a while nawala ang video.
Mga yan mo sa file sa PPT, sir.
Oh, yes, ako ni siyang i-provide ang ako ang ato ang lecture materials no for this week. So as well as kani ako ang virtual whiteboard. So ako ni siyang i-download as PDF form then ako siyang i-upload sa ato ang UStep. So by the way, nag-upload na ko sa ato ang UStep no sa atong core syllabus and also katong PowerPoint no but in PDF format sa ato ang UStep. So ako na siyang upload dito. So, if you are interested to review the syllabus or the topics sa ato ang dynamics, then you may access it sa ato ang UStep, no?
Dili na din taga kuan sir, classroom.
So, again, mo na kong giingon last meeting no
Ah,
nga we will be using Google Classroom and UStep. However, na-realize na ko na why not i-maximize nato or i-utilize nato ang official learning platform sa tong university which is ang UStep. So as much as kaya nako i-discover or i-maneuver no, maneuver good ang UStep kay dili pa gyud ako siya totally nasabtan or dili pa gyud ako siya wala pa na ako na expert kay bali ba no ang every function sa UStep murag daghan kayo siya og tuplukonon so basin naay mga assignments no nga dili na ko makita so or basin na mo yung mga submissions nga dili na ko ma-view or wala ko katuod kung asa siya i-view. So sige lang ako sa ning studyhan and magpa-seminar sa ako ani sa akong kauban. But initially I think UStep na lang gid siguro ato ang gamiton no. But nevertheless, if ever man gali na um, maglisod ta sa UStep no, so mag-Google Classroom na lang siguro ta. So sige lang, mag-create ra gyud gyapon ko og Google Classroom as backup na to no. Kay I think na-feedback man god na sa UStep daw kuno ga-crash daw siya from time to time, especially during examinations no, midterm and final exam. So which is understandable kay daghan man ga-access na no, ana nga time no kay midterm exam man so of course every student no is required to take the midterm exam. So, magdungan-dungan og access or magdungan og open sa UStep. So, na siya tendency yun nga mag-bug no or mag-crash. So, isa siya ka-factor na pod nga ma-delay base ang inyong submission sa inyong output no sa inyong quiz ba kaya or sa midterm exam or final exam man jud mismo. So, sige lang no. Wala pa jud ko to be honest, pa jud ko naka-fully decide kung UStep alone or both Google Classroom or UStep. But so for now, sa UStep lang yapon ako siya i-upload. So I'll give you feedback na lang if naana tayo Google Classroom or if mag Google Classroom na lang ta. So ana lang no.
thank you sir.
Okay, sir.
Thank you, sir.
So wala na
Thank you,
ba
sir.
may questions or clarifications kay before ta mo i-dismiss mag-attendance sa tanong. For a while ha. So say present if naakakaron sa meet. While asa to inyong okay. So this is CE2 2L, no? February 14. Okay. Aberin Monique.
Present, sir.
Abrenica Hannah Grace.
Present, sir.
Asebar Maria Christine.
Walang
Baconga.
sir.
Okay, sige lang. Baconga Lloyd Vincent.
Present, sir.
Pastatas Joby.
Present, sir.
Payotas Monique Grace,
Present, sir.
Beniga Janiel Rose,
Present, sir.
Bonglay Joey,
Present, sir.
Kailing Joby,
Present.
Biharme Paul Joshua,
Present, sir.
Econar Dondi, Jeffrey,
Present, sir.
Malagamba Christian Clint. Okay. For a while na i-feedback. Nawala daw internet. Sige. Okay, so Medallia Rosel.
Present, sir.
Tama ba kung pagka-pronounce mo name? Medallia Rochelle, or?
Rosal, sir.
Okay, sige. Thank you. Meriales Joyce.
Present, sir.
Mugot Ryan Van.
Present, sir.
Nahial Lendi.
Present, sir.
Tama ba ang akong pronunciation? Nahial Lendi?
Yes,
Or,
sir. Nahiyan.
okay, I thought okay. Thank you. Nisperos Paul Vance.
Present, sir.
Oclarit Eliza Nicole. Ortiz Lord Vincent.
Present, sir.
Pakana German.
Nawala daw ang kuryente sila, sir.
Okay. Perihan Jezreel Vincent.
Present, sir.
Udadera Kiro Clemens.
Present, sir.
Sakuan Arlegin or Sakwan.
Sakwan, sir. Present,
Okay.
sir.
Okay, thank you. Saging Jason.
Present.
Saniko Starian Miles.
Present, sir.
Okay. Sharif Muhammad Ali. Sultan Rodelin.
Present, sir.
Abuelo Dems Lester.
Present, sir.
Kandong Justin Bryle. Adlas Marybel. Tambis Jomar.
Present, sir.
Tao Mary Josephine.
Present, sir.
Present daw
ha.
si Tadla, sir.
Okay, sige. Thank you. Tadlas, no? Texon Maureen.
Present, sir.
Chu Contreras Kirby. Oh. Okero Loveline.
Naato siya ganina, sir, si Kirby.
Present, sir. Present.
Okay, sige. Valdueza Shane Can.
Present po.
Villanueva Ren.
Present, sir.
Ibanez Kim Harold.
Naa siya ganina Japon, sir, pero nawala yung connection right now.
Sige. So, thank you sa feedback para po makonsider nato. Zacharias Prince Edward.
Present, sir.
Okay. So, si Zacharias Prince Edward ang last akong list, no? So, if naay student nga wala na tawag, kindly, na lang, chat your full name diri sa to ang chat box para ma-consider na to ang imuhang attendance today and also para madugang nako sa akong class record, no?
Okay, sir. Thank you.
Okay, so I think natawag man siguro tanan, no? So if wala na mo laing concerns and clarification, so say see you next meeting, no, for this class, no, kay makita pa man ta tomorrow. So thank you for your participation today. Good afternoon and class dismissed. Happy Valentine's.
Happy Valentine's, sir.
Thank you, sir. Bye,
Bye.
sir.
Bye-bye, God
Thank you,
bless.
sir.
Bye, guys.
Thank you, sir.
Mhm.